Today on the Tech Bytes podcast, we're talking about cloud storage. More specifically, we'll dig into maybe why it's time for NFS to sail off into the sunset, particularly for cloud data sets. Our guest is Tom Lyon, a computing systems architect and entrepreneur. And I'm not going to read you Tom's full bio here, but it's impressive. He's had a long career in the IT industry, including being the founder of multiple companies, an early employee at Sun Microsystems, and a contributor to the Unix kernel. Our sponsor today is MinIO, but Tom is not an employee of MinIO. He just wants to share his views on why object storage is a better option than NFS, particularly for data sets in the cloud. So Tom, welcome to the podcast. And before we dive into it's time for NFS to die, can you just give us a little bit of background on yourself and your career?
I've mostly been a networking guy since back at Princeton when I was trying to get a PDP-11 to talk to IBM mainframe. And that was most of my career at Sun Microsystems, where I was one of the NFS contributors, and started several companies after that. A couple of them have done well financially, but people still haven't heard of them anymore these days. So we'll skip that.
Okay. Well, I guess it's a good sign if you start a successful company and then it just gets absorbed into another company is what I assume happened.
I am, by the way, retired for the third time, and my wife has promised to kill me if I start another company. So what I'm talking about today is an idea for more of an open source project.
Okay, so let's dive into that then, because sort of the theory of this recording is NFS must die. So let's start talking why.
Well, NFS was a very carefully selected set of trade-offs chosen 40 years ago. And next year, it'll be officially 40 years since NFS shipped. And the whole paradigm doesn't quite work in the cloud age. We've learned a lot about distributed systems since then. If you look at cloud storage, right, there's three types. There's block storage, object storage, and file storage. Object is really the only cloud native storage technique pretty much invented by AWS. So they could have something simple that scaled to a worldwide degree. You can have a browser in Botswana access a server in Cydonia, all residing on data centers in Virginia or whatever, but it's a very impressively scalable system. Files just have never scaled to that extent. Blocks aren't really there for scaling, but they work very, very well because they're trivial semantics. You can read and you can write, and that's pretty much it. So if you look at files and what's the problem with NFS, and it's not really just NFS, it's pretty much any approach in network file sharing. And so the first thing that's wrong with it is the paradigm is just all wrong. It encourages multiple users to access shared writable data spaces. And one of the most important lessons we've learned in distributed computing is that shared mutable data is a really bad idea. Things get out of sync. You can't synchronize multiple actions. Everyone has a slightly different view of the data. So it's a huge mess, and you can't really build strong semantics on top of that. And this is usually talked about in the context of programming languages, like when you're fighting over shared memory. So we've had languages like Erlang and Go that discourage it, and languages like Rust that really prohibit it. And they have a much more successful approach to concurrency. The same thing happens when you have distributed systems, only now you have a flaky network in the middle as well. So things get much, much harder.
Yeah, a flaky network as in you can end up with partitions and separation of network segments that cause challenges for the distributed system.
Right. Exactly. And you're never sure, did the network go down? Did the remote end go down? Did I go down? Who knows? So another big problem is everybody wants slightly different semantics, right? NFS has a subset of POSIX, and it was always, criticized for not meeting the POSIX standard, even though that is in fact a moving target. And NFS and POSIX came out about the same time anyway. So the semantics are iffy, but particularly for POSIX, if you look at the modern understanding of networking, the CAP theorem, you mentioned partitioning. The CAP theorem says you can't achieve both consistency and availability in the presence of partitioning. And in the NFS days, we kind of discovered this the hard way, and we had to make the option for soft mounts and hard mounts. So hard mounts if you wanted consistency, guaranteed you're not going to screw up your data. Or soft mounts if you want availability, meaning you can actually get work done when the server crashes.
You're arguing that NFS must die, but yet it has had an awfully long run, as we pointed out. I mean, NFS is everywhere. It's baked into everything. It's used very commonly. So is there a...
But it's not. Okay. It's never used at scale, right? And the trouble with NFS is you pretty much need a human babysitting things when things go wrong. Because when something goes wrong, you're never quite sure where to fix it. And that's what gets me about cloud scale things. Things have to be 100% reliable to be deployed at the scale that happens in the cloud.
Okay, so the challenge here, and what you're advocating for is when you need to operate at scale, NFS and similar file-oriented storage protocols are not the way to go. There's too many problems to be able to function at scale without inconsistencies coming up in the data and so on.
And the semantics have never been well defined, so you can end up in situations where you think your program is behaving in a way that's going to work fine on NFS. But then you get an updated library from somebody who did something that uses some new file system feature that doesn't work. And it all starts to crumble. So how do you prevent that kind of thing? And there's really no definition of what semantics work well with files. There's the local file systems, even ext4 and XFS differ in subtle ways. There's the system call interface, there's the protocol standards, there's the POSIX standards. So which semantics are you going for? Nobody knows. And so I argue the only reasonable mainstream thing is the semantics of a local ext4 file system, because that's what everybody has. Therefore, if you make that work, it'll work pretty much everywhere. So the semantics are messed up. And then, of course, the security model of NFS has never been usable in a multi-administration way. So you can't have NFS sharing across administrative domains.
So when we're talking about scale, what kind of scale are we talking about? When does that sort of switch happen between NFS is inappropriate because of scale versus object storage?
Well, the killer feature of NFS is you can access arbitrarily large data sets with network oblivious programs and kind of poke around in a data set without having to copy the whole thing first. Mm-hmm. So that's the killer thing. So how do you get that in a cloud scale way where I can use grep on some data set that somebody made available to the public, and it happens to reside in AWS in the US, but I'm grepping from China? How do you make that work? That's the cloud scale I'm talking about. Okay. And how do you make it really easy? And I have an approach to all this, and I gave a talk at the Netherlands Unix user group starting to outline all that, but it gets kind of hairy to get into. But basically, if you look at cloud scale file sharing, there's two really vivid examples today. One is Git. So the Linux kernel, people develop it all over the world. I don't know, 30,000 developers. And it scales. Docker files are kind of similar. It's spread all over the place. And what those things have in common is that they use layered, immutable versioning, so that anything you share is fundamentally immutable. And when the next version comes along, it's a new layer on top of the old stuff. And you can never share anything until it becomes immutable. Because it's immutable, it can be copied and cached arbitrarily for arbitrary amounts of time, and never needs to be invalidated. So if you take the same approach in a way that's much friendlier to arbitrary POSIX programs, you can build a much better approach.
Caching being critical to the scale aspect of this. We can't scale big without the cache.
Plus, if you're using a normal Linux file system, it expects to be able to cache blocks underneath. And that's really critical for performance. I mean, I use NFS at home, because I'm one user, 5 machines or whatever. And it's still particularly slow every time I want to list a large directory. So there's ways you can achieve what I have in mind is basically you access the data set. When you access it, you get your own writable layer on top of the immutable data set. So it looks like a writable file system. You can use whatever programs you want. But when it comes time to share that, that's when you have to freeze it and make it immutable. So you have the equivalent of a git commit. And at that point,
okay,
off you go.
It's very different from file locking, let's say.
Right. This is more at, we get rid of doing anything at the file level and do it at the file system layer level. So the unit of administration and tracking becomes a lot more granular. The thing that enables the layering is the overlay FS, which is also used in Docker. And it's a great grandchild of what we at Sun call the translucent file system, which I'm one of the patent holders on. This stuff has been living in my head ever since the NFS days. It's like, how can we actually do this right?
So how close is what you're describing to if we were to examine S3 as a protocol? Is it quite similar, quite different?
Well, quite different. It's S3 is the object protocol, right? And what I'm proposing is not really about the protocols. It's more about leveraging existing file systems and overlay FS with existing protocols. You need a block protocol for writable storage, but as soon as you freeze it, you can snapshot it to your object storage system, and that gives you worldwide access in a fairly trivial way. So, but you're snapshotting again at the file system level. So it's a much more granular thing. So you can totally use this with object storage, except for that first writable layer where you either want local writable storage or something coming over NVMe over fabrics or something like that.
So what is the name of this project you're talking about?
I call it Beyond File Sharing, BYFS, BIFs for short.
Mm-hmm.
The downside of all this is I am not capable of engineering anymore. So there's essentially zero actual progress on this. But that's why I'm soliciting collaborators, especially people for whom this might be a real problem. We need the users to help drive a open source project.
So Tom, you're looking for a specific sort of a user that would be interested in this?
Somebody for whom, cloud scale file sharing is a problem. And I don't know for sure, but I imagine a lot of the AI stuff where the data sets are gigantic. Mm-hmm. They want to distribute data to thousands of GPU nodes and do it in some consistent way. So they probably have a huge versioning problem. And there's been lots of other layered immutable data facilities, like the Delta Lake in the cloud is very popular in the, I forget the name of the company, but in the Java world. And there's a system called Pachyderm, which the original tagline was "Get for your data." So there's a lot of similar approaches, but none of them accomplish the NFS feature of never having to copy stuff before you use it.
That is being able to do it over the network and have the network be transparent to that transaction.
Right. Because of the cap term, it'll never really be entirely transparent. Yeah. And again, in the cloud, it's not a human very often who's doing this stuff. It's deeply embedded. So a person using the system is now some kind of process or job or agent or something. And if something goes wrong because of the network, the right thing to do is just restart everything. Restart that job. Humans don't like to be restarted, but in the cloud, it's totally the right thing to do.
So I've got a couple of takeaways here. One is you've got this idea beyond SF. You're looking for collaborators, but you're also saying that it can tie into object storage underneath. Absolutely.
It's object storage is the way to do cloud storage. It's cheap. It's fast enough. File sharing, in my mind, in the cloud is just an abomination left over from the enterprise world. And block storage it's fine. It's very well defined semantics, and it's necessary for compatibility of all these old operating systems.
Okay, so what I'm taking away then is that, and you're saying object storage is ideal for public and private cloud because of performance, scale, and cost.
Right. Yeah. I mean, I talk about cloud. There's an awful lot of cloud native things happening on-prem these days as well.
Mm-hmm.
And just the ratio of machine to user, is 1,000 times bigger than it used to be, or at least 1,000 times. So things have to work really, really well-defined ways, in scalable ways to have a place in the cloud native world.
So is there a place folks can go if they're interested in BYFS and want to take a look at it or see if they want to become a collaborator?
There are both slides and a video from the talk I gave. This was at the Netherlands Unix Users Group, which a bunch of old farts like myself. But you can find that on the web, and I think we'll reference it in the show notes.
Yeah, we'll absolutely have those links in the show notes. Well, thank you, Tom, for joining us. And we will have those links in the show notes if folks are interested in the BYFS project and want to get a look at it and see if they're interested in collaborating. We'll also have some ways to contact Tom to get in on this. We'd also like to thank MinIO for sponsoring this episode. If you would like to find out more about what MinIO is up to in regard to object storage, just head over to min.io. You can get more details and read their technical blogs or download it and try it for yourself. Thank you for listening. You can find this and many more fine, free technical podcasts and our community blog. It's all at packetpushers.net. You can find us on LinkedIn. You can hear us on Spotify. And if you would, leave us a rating on Apple Podcasts. And last but not least, remember that too much networking would never be enough.